Hello everybody, my name is Stephen Kwan. Today I'd like to spend a few minutes talking to you about our Bentley Performance online performance monitoring software solution. First, a quick product overview. Bentley Performance is our online performance monitoring solution that's integral to our System 1 condition monitoring software platform. Bentley Performance was built to target the upstream and downstream oil and gas industry. By leveraging the capabilities that are in System 1, we're able to provide a solution that archives and displays both vibration and performance data on a single software platform. In addition, the calculation results from Bentley Performance can be processed by our decision support software, which is an extension to System 1. One of the key advantages of Bentley Performance is its ability to perform calculations at a very rapid rate. Bentley Performance allows us to provide a solution that monitors machinery-level performance degradation over time. So in the case of process compressors, Bentley Performance provides information to the user in order for the user to monitor surge and surge margin. Bentley Performance provides calculation results on the actual polytropic efficiency and head, the actual gas power, the actual pressure ratio and temperature ratio that the compressor experiences. At the same time, this information is displayed to the user on a unified display screen in comparison with expected equipment performance level at design condition. In the Bentley Performance calculation engine for process compressors, we implement the industry-accepted ASME test codes. In addition, we apply various equations of states, some of which you can see on the screen, and the proper application and configuration of these equations of states is based on the operating condition and also the fluid types that goes through the process compressors. In addition, Bentley Performance requires some additional inputs in order for it to perform its calculations. Some of the inputs that's needed by Bentley Performance are typically available from the DCS in an online fashion. Some examples include pressure, temperature, and flow, and also fuel constituents, or fluid constituents. In cases where online data is not available, Bentley Performance allows the user to manually input the required data into the software. Some examples include manufacturer's design data, such as compressor maps. Here is an example of a display screen for a two-stage compressor being driven by a driver. As you can see, System 1 and Bentley Performance provides the user the capability to view all pertinent performance calculation results in a single display screen. For process compressors, our Bentley Performance solution provides compressor maps to the user where we display the actual calculation results versus the manufacturer's expected results at design conditions. By displaying all this data on a single display screen, the users are able to compare the actual performance with the expected performance, thereby able to discern any performance degradation at that particular moment in time. Bentley Performance also allows the user the capability to trend their performance parameters over time, thereby allowing the user to assess the relative performance degradation over time. As an example, here we're displaying 4 trend plots over time for some machines that are being monitored by our thermal performance software. The battery performance calculation results can be used in our decision support software, allowing the user to configure alerts and alarms and actionable information based on the calculation results. All these functionalities are available within our System 1 Condition Monitoring software platform. In the case of process compressors being driven by gas turbines, we have a software solution that advises the user as to the optimal time to perform gas turbine compressor wash. As an example, here's a display screen for the required inputs for a compressor wash advisor for gas turbines. The compressor wash advisor accounts for all major wash-related costs. For example, the cost of the fuel, electricity, and the cost of the water and associated detergents that are needed for the compressor wash. Also, the compressor wash advisor allows the user to designate the expected performance recovery historically on compressor wash. That information is used to determine the optimal time to perform the compressor wash based on economical drivers and the various data that the user provides. The compressor wash advisor allows the user to configure these parameters individually for every gas turbine that they have in their fleet. In determining the optimal time for the compressor wash, what the software does is it considers the actual gas turbine degradation over time, and by comparing that with the actual cost of doing the compressor wash, the software does an extrapolation over time on the trend of the actual gas turbine degradation. The software takes into account machinery downtime and also different rates of degradation. By performing this calculation frequently, perhaps once a day, perhaps once a week, as time gets closer to the optimal time of the wash, the prediction becomes more and more accurate. Here is a screenshot of the user interface that's available from the compressor wash advisor to the user. And what the software provides to the user is an assessment on how close it is to the optimal wash date projected into the future. By doing so, the compressor wash advisor provides a projection into future for the optimal time for performing the compressor wash. For additional information, please contact myself, Stephen Kwan, at Stephen, S-T-E-P-H-E-N Kwan, K-W-A-N, @ge.com, and my telephone number is 775-215-1871. Thank you very much for your time. Bye-bye.